Dear viewers, today I am going to show the advanced BLDC drive developed by National-Infotech. So in this part we will discuss about the closed loop control of the advanced BLDC drive. So this is the full setup of advanced BLDC drive. So now you can see this code is for closed loop control of BLDC motor using PWM technique. So by pressing Ctrl B you can build your code into the controller. Okay, all the connections I have already discussed in the part 1. Okay, so you can make your connection by seeing this part 1. Okay, and this is the motor, HPM, rapid development kit. Okay, so now you can see code is done. Okay, so some changes in this code because it is closed loop mode. Okay, so first of all we will discuss this screen and the key functions. Okay, so here you can see the open loop or closed loop mode. So here this is the closed loop mode, on or off, system on or off, you can see from here. Okay, here you can see the direction, clockwise or anti-clockwise. Okay, here you can see the duty. Okay, here you can see the reference speed, and here you can see the actual speed. Okay, because it is a closed loop system, so whatever you can apply the speed, you can get the actual speed with any loading condition. Okay, and here you can get the duty according to your PI. Okay, and here you can see the speed direction. So two function is same. By pressing this K5 you can turn on or turn off the system. Okay, by pressing this button you can change your direction. Okay, and by pressing this button you can apply your reference speed to the actual speed. Okay, because this is a closed loop system. Okay, so if you want to change your speed to 500 to 1500 RPM, then you can set this reference speed by using this analog port. Then you can apply the this speed to the controller. So by pressing this K4 button you can apply your reference speed to the controller, so it will take some millisecond to get your actual speed. Okay, and duty you can get according to your PI, and here you can connect the encoder input. Okay, same if you can disconnect your Hall sensor in between working with the motor, or in between that it will not work, system is not work. Okay, so sensor is not connected, you can see this display. So first of all you can connect your encoder, so it is turn on the system, and you can see the speed, actual speed and reference speed. Okay, then if system is off, then you can change your speed direction counterclockwise or clockwise. If system is on, then you can't change your speed direction. Okay, but in the working condition you can apply any speed anytime. Okay, so you can vary just this port, and you can set your reference speed. Then in between the working you can press the K5 to apply your reference speed command. Okay, so now all the connections are same. So now we will see the performance of this motor drive in the closed loop system. Okay, so now once I have restart this controller. Okay, so you can see my controller is restart. Okay, so at the starting your reference speed is, if you have your set your reference speed is 1800 RPM, then it will not take this reference speed. Okay, in this code we have developed at starting your reference speed is set to 500 RPM only. Okay, once it is adjust at 500 RPM, then you can apply your actual speed whatever you want, okay, by pressing this K4 button. So we will see these things, okay. So now by pressing this K5 you can turn on the system, okay. So system is on, speed direction is counterclockwise, okay. So you can see it is working with the counterclockwise direction, okay. And you can see as per my discussion, whatever initial speed you can set in analog port, it will not take at the initial time, it will take only and only 500 rpm, okay. Then after you can press K4 button, then it will take your command, it will take some second, and then after it will take your command and adjust your reference speed, and actual speed is same, okay. So you can see your reference speed is 179293 rpm, then it is tried to maintain at reference speed, okay. So now you can see it is working with the no load. So you can see at this time your current is 1.3 ampere, okay. So now I have applied the load, now at this time we will check this performance at 8 ampere current, okay. So you can see I have applied the 8 ampere load, okay. So it is try to maintain at actual speed with reference speed. So you can see it is try to maintain, okay. And your duty is vary because PI is now working, okay. So it is try to maintain at actual and reference speed same, okay. Now we will see the performance, okay. So you can see here your actual speed is same, okay. And here you can see the current IR and IY, okay. So from here you can see, okay. Now again you can vary this port to apply another speed. So I am varying this port to maximum, okay. Then it will not take immediately, so you can press this button K4 to set your reference speed command, okay. So you can see my reference speed command is taken, so my actual speed and reference speed is now match, okay. And duty is up to 91, so our saturated duty is 95%. So if you can get the duty is 95%, then your duty is saturated, you can't get the reference speed command as it is with actual speed, okay. So you can see current is 8 ampere, okay, and it is working fine. So you can see the current, okay. So this is the loading condition where it is working properly, okay. Now I have removed this load to 0 and see the performance, it is working perfectly, okay. I have removed this load and you can see the speed is again maintained at the reference command, okay. Now by pressing this button you can turn off the system and you can change the direction, wait for the system is stopped, okay. Now you can change the command to counter clockwise direction, then you can start the motor, okay. So at this time whatever last command you have applied, it will directly taken, okay. So you can see it is started, okay, and duty is 40, 50, around 50, okay. Now we have applied the load to 8 ampere. Okay, you can see I'm increasing the load and current is gradually increased. At this time I have applied the load up to the 9.5 ampere because motor is 10 ampere motor. Okay, and see the performance, it is working or not. Okay, I have applied load to 9.2 or 9.5 ampere, so I am increasing load to 9.5. So you can see the current is set to 9.4 ampere, and now we will see the performance of our control. So you can see reference speed is 2497 rpm and your actual speed is same. Okay, and your duty is not saturated, and also you can see in the tachometer, okay, it is maintained at reference speed command, and this is the current. Okay, so this is the full setup of the advanced BLDC drive. So this is the working of the closed loop system. Okay, so thank you.